The interface is normally two molecules, but its area depends upon size of the particles or the bulk phases. So it depends upon the size of the particles or the bulk. So using the slash, the interface is using the slash. Visualization apparent interface. Solid was also found for many applications in industry and technology and daily life situations. Okay. So under high vacuum, when we have to obtain a limited surface, we have to use high vacuum around like 10 to the power of minus 8 to 10 to the power of minus 9 pascals. So solid materials with such clean surfaces need to be stored in vacuum. Otherwise, this will be covered by the normal atmospheric gases like nitrogen and oxygen. So what are the points in this page? So due to the complete visibility, there is no interface between gases and they cannot be represented by a slash between the interfaces. And the interface is normally a few molecules thick, but the area of the interface depends upon the size of the molecules and the bulk particles. So the bulk particles were like big, the area of the interface would be more thicker. So the solution and crystallization, others, I didn't know that this is a surface phenomenon, but dissolution and crystallization is not really sure. So when you have to have a very ultra clean surface on metals, like you have to apply a vacuum of around 10 to the power minus 8 to 10 to the power minus 9, which is like 1%. Just after that, and then you have to store them in vacuum so that they don't get found by nitrogen. Okay, so what are the several examples? You can bring the surface. These molecules remain outside the surface and do not go deeper into the bulk. As also atomic molecular species in the surface. So these are molecular species. I don't think molecular species. Absorption is essentially a surface phenomenon. Solids, particularly in its finely divided state, have large surface area and therefore charcoal, silica gel. Okay, now we've dealt with this already. Charcoal, silica gel, alumina gel is for metallurgy, clay, colloids, metals in finely divided state. So what gases are given here? Oxygen, hydrogen, nitrogen, chlorine, ammonia, sulfur dioxide. No carbon dioxide here. So if it is taken in a closed vessel containing powdered charcoal, it is observed that the pressure of the gas in the enclosed vessel decreases. Gas molecules bounded to the surface. A solution of an organic dye melted into absorbed on the surface of charcoal. Solution is well shaken. It is observed that this filtrate turns colorless. The molecules of the dye thus accumulate on the surface of the charcoal and are absorbed. aqueous solution of raw sugar will pass over beds of manual charcoal. It becomes colorless after coloring substances are absorbed by the charcoal. So aqueous solution of raw sugar passed over beds of manual charcoal again. The air is flushed into silicates and the water is silicates. Okay, good. So it's clear from the above examples that solid surfaces can hold the gas or liquid molecules by virtue of absorption. Okay. So this is important. So when you dip chalk into it, we observe that the inner surface still remains white while the outer surface gets covered by ink. That is because absorption is happening but not absorption, and unbreaking. So in absorption, the substance is uniformly distributed throughout the bulk of the solid. A distinction can be made between absorption and absorption by taking the example of water vapor. Water vapors are absorbed by anhydrous. This is very important. So anhydrous calcium chloride drying agent. Water vapors are absorbed by anhydrous calcium chloride while they are absorbed by silica gel. This is very important. Absorption rises due to the fact that surface particles are not the same in the environment. Of course, this is all freak shit. So the extent of the absorption increases with increase of surface area per unit mass at a given temperature and pressure. So the extent of absorption increases with the increase in surface area per given mass at a particular temperature and pressure, and the mass increase referred to the adsorbent. Okay. So another important factor during absorption is the heat of absorption. During absorption, there is always decrease in the residual forces of the surface. Okay. So there is decrease in the surface energy. That means the heat is released. It was already very unstable. Now it's stable. Thus the heat is getting released. And absorption enthalpy. That's why absorption enthalpy is always negative. It's always exothermic, or else it wouldn't happen. So absorption is negative. When a gas is absorbed, the freedom of the movement of the gas molecules become restricted. This amounts to decrease the entropy of the gas after the absorption. Delta S is negative, of course. Exothermic, so negative. Entropy is negative, so negative. So that T delta S minus T delta S term would be positive. That means the del H term has to be sufficiently negative to make the del G negative. So that has to be taken care of. It has to be extremely exothermic. If they become equal, equilibrium is attained. Constant temperature and pressure. At constant temperature and pressure, del G must be negative. There is a decrease in. There are mainly two types of absorption of gases on solids. Conversion gas of solids. Physisorption and chemisorption. So these are types of absorption of gas on solids. Okay. So the chemical bonds may be covalent or ionic in nature. The chemisorption involves a high energy of activation, therefore it is an activated absorption. Okay. In chemisorption, the bonds may be covalent or ionic in nature. Chemisorption also involves a high energy of activation, like every other chemical reaction, and also referred to as activated absorption. Dihydrogen is first absorbed. Dihydrogen is first absorbed by van der Waals forces, which is not very much, but still it is. Then it gets held to the surface by chemical bonds. Physics option, lack of specificity, whatever has a van der Waals force get attracted. Nature of the adsorbent, the amount of gas depends on the nature of the gas. Easily liquefiable gas have like higher intermolecular forces, and they then tend to come together and settle down. Like that you can, for hydrogen would be the least because it's like 33 Kelvin. Has a critical temperature 33 Kelvin, so it tends to not liquefy at room temperatures. And then methane also same. Sulfur dioxide, it is easily liquefiable. Okay, it sulfur dioxide bigger and also has oxygen. So I mean, no hydrogen not possible, but still oxygen is biggest molecule, and sulfur is also even bigger. So CH4, H2, SO2. So reversible nature. This is also reversible. Everybody knows this. But still it can be written in the form of an equation, like equilibrium equation, where heat is released, and by reasonable principle you can do whatever the shit you want. Okay, surface area of the adsorbent. Extend the adsorbent, increase its surface area, thus fine environmental and porous substances having glass good adsorbents. Absorption. This is very important. 20 to 40 kilojoule per mole in physics option, from 80 to 320 if I recall correctly. 80 to 240. 80 to 240 kilojoule per mole in chemistry option. Chemistry option is highly specific. It will only occur nevertheless it is still exothermic. This substance is highly specific, and it will only occur if there is some possibility of chemical bonding. You cannot expect chemistry option to occur with helium and neon and all. So physics option definitely occurs, but chemistry option doesn't. So okay, irreversibility. It is also irreversible because chemical bonds are getting formed, so you have to give them. Okay, usually high pressure is also favorable for chemistry option, of course. Like physical absorption, chemistry option also increases. The variation of the amount of gas absorbed by the absorbent pressure is found at constant temperature. That's why it's called an isotherm. So it's termed as absorption isotherm. So temperature remains constant. We vary the x by m term with pressure. So x by m is called Kp 1 by n, where n is greater than 1. So of course n is greater than 1. The possible values of 1, n is 2 to 10. So it can be anything from the n can be anything. The 1 by n can have anything from 0 to 1. That means from infinity to 1 to infinity, it can have any values. The probable range is 0.1 to 0.5. That would mean 10 to 2. No, 10 to 5. 0.5. So 2 to 10. So 2 to 10 would be more appropriate. 2 to 10 would be more appropriate. It can go anywhere from 1 to infinity n. So if it goes, so let us just check our thoughts. So 1 to n can vary from uh, one turn can vary from 0 to 1. That means one turn n can vary from infinity to 1. So the most probable range of 1 by n is 0.1 to 0.5. That would be the probable range of n would be 10 to 2. So 0.1, 10, 5, 0.2, 0.5. From this isotherm explain the behavior of absorption. Why do we say this is fixed pressure? We don't say this is exactly fixed pressure, but like for line with a certain pressure, you can see that higher temperatures have higher curves with more slope. So n is greater than 1. That means n varies from 1 to infinity. So the graph doesn't start at 0. Okay, this is so the line is straight line passing through the origin? No, it doesn't. So it is a straight line that it follows from its isotherm. If it is not, it doesn't. So it is only good for holds good for a limited range of pressure, and at a constant pressure, if you try to draw isotherms at different temperature, the higher isotherms would show lesser slopes because physics option, right? Okay. When 1 by n is equal to 0, that is n is equal to infinity, it is independent of pressure, and 1 by n is 1, that is n is equal to 1. Atmosphere absorption is direct to pressure. Both the conditions are supported by experimental results. The experimental isotherms are the same to observe acceleration at high pressure, therefore Frohn's isotherm fails at high pressure. Okay. So solids can absorb solute from solution also. The same thing, just replace the P with C. Litmus solution when shaken loses its color. The precipitate of magnesium hydroxide when shaken with the magnesium reagent becomes blue because of the because of the absorption of the magnesium reagent particles on the MgOH white, which is colorless. It was originally colorless, now it's blue. It was very nice color. So the color is due to absorption of magnesium. The extent of absorption decreases with an increase in pressure. The extent of absorption increases with an increase of surface area of the absorbent. Say it depends on the concentration of the solution. Size mechanism of the solution is not known. This and that can have increase in pressure. So this is the approximately describes the behavior. Difference that instead of pressure, concentration of solution is taken into account. plotting log x by m against log c of straight line is obtained is obtained from this isotherm. This can be tested experimentally by taking solution of different concentration of acetic acid. So that is x, right? So you can't measure, you can't take the solid out and measure how much acetic acid you have absorbed. You can't. So what you do, you let it absorb, and you have to measure the initial value of the acetic acid concentration, and then the final value of the acetic acid concentration, and you find the mass, and now you find the mass per the mass of the original adsorbent. Application of adsorption. High vacuum is produced, of course. The remaining traces of air can be, no, this cannot be used as a primary like a vacuum creator. If some few molecules here and there you need to absorb them, then charcoal is the job. That is the job. So vacuum pump to give a, already it has to be evacuated by a vacuum pump to give a very high vacuum. Gas masks. Gas masks absorb poisonous substances. They contain activated charcoal or a mixture of adsorbents used for breathing in coal mines to absorb poison. Control of humidity. Silica and aluminum gels are used for adsorbents to aluminum gels. Heterogeneous catalysts. Almost all catalysts are heterogeneous catalysts actually. So for gaseous reactions, all catalysts are used. For example, iron catalyst in Haber's process, V2O5 in contact process, nickel hydrogenation of oils. Due to difference in degree of absorption of gases by charcoal, a mixture of noble gases can be separated by absorption on coconut charcoal. Coconut charcoal, that is kind of different. We dealt with animal charcoal so far. So coconut charcoal at different temperature. Separation of noble gases. A number of drugs are used to kill germs by getting absorbed on them. Okay. So Froth flotation process. Silica. So it enhances non-wettability of the metal. The frothing agents. Certain precipitate such as silver halides have the property of absorbing some dyes like eosine fluorescent, and thereby producing characteristic color. They produce a characteristic color at the end point. This was actually the preparation of oxygen. Like it decreases by 200 degrees Celsius in the whole thing.